Concept 7c, graphing quadratic functions in intercept form. Let's start this section with some vocabulary definitions and formulas. So we're going to look at quadratics in what we call intercept form. That means that the equation is in the form so that we could look at it and see what values the parabola is crossing the x-axis. So it's a quadratic function in the form f of x equals a times the quantity x minus p times the quantity x minus q. So this is where p and q, they are constants, so they're numbers, and those are the places where the parabola is crossing the x-axis. So those are the x-intercepts, and we can think of them as 2 points. So for example, if the equation was something like y equals, the same as f of x, 2 times x minus 2 times x plus 3, our p value would be 2, our q value would be negative 3. Because notice the formula is in terms of subtraction. So what do I subtract to get x plus 3? Well, I subtract a negative 3. So that means that parabola would cross the x-axis at the points 2, 0 and at the points negative 3, 0. Another definition to get down is x-intercepts. This is the points where the parabola intersects the x-axis. Also, a few more things just to recall from our last concepts. Minimum or maximum. This is the highest or the lowest point of a parabola. And then we're going to continue to talk about domain and range. Remember, the domain is a description of all the values that we can plug in for x that will give us real number outputs. The range is what happens when we put in the domain. It is the set of the possible outputs. Now here are the steps to graph a quadratic that's in x-intercept form. So the first thing you want to do is look at the equation like before and anticipate any transformations that might occur. Then you're going to start by finding the x-intercepts. So you're simply going to pick out the p and the q values based on where they are in the equation. And those will be the x-intercepts, the point p0 and the point q0. Then you're going to find the axis of symmetry. In intercept form, we find the middle of those x-intercepts. So we take p and q and add them together and divide by 2. And that will give us the middle of those intercepts, which is the axis of symmetry. That is also the x value of the vertex. So p plus q divided by 2. And then to find the y value of the vertex, you plug in that x value that you just got. And that will give you the x and the y for the vertex. Then, just like before, you're going to make a t-chart and find 2 values in the negative direction of the vertex and then 2 in the positive and graph it. So let's start with f of x equals 1/4 x minus 6 times x minus 2. So if we anticipate transformations, we can see that our a value is less than 1. If it'll let me, there we go. And so that means we're going to have a graph that is a vertical compression or a shrink, so it's going to be wider. I'm going to pick out my p and q values. So p is 6. Q is 2. So that means I have the point 6, 0 and 2, 0. 6, 0, 2, 0. And actually this method is a little bit different because rather than starting with the vertex, we start with those x-intercepts. The vertex is in the middle of them, so I place them like this in my t-chart, where I leave a space in the middle for the vertex. So the axis of symmetry, which is also the x value of the vertex, is p plus q divided by 2. So that's 8 divided by 2, which is 4. So that is the x value of the vertex. Now I'm going to find the y value of the vertex by plugging in 4. Now when I plug in 4 to my function, I get -1. And I see that my slide has skipped on to example 2, so hopefully you went ahead with me, and we'll just graph example 2 first and then go back and get example 1. So now let's draw an xy axis. I'm going to try again because I kind of missed there. And label a scale. I apologize, it's difficult to make a neat graph on this thing. So my first point is at 6, 0. Then I'm going to do 2, 0, and then I have the point 4, -1. So this is just 3 points to graph my parabola, but I can go ahead and do it. My axis of symmetry is, remember, the x value of the vertex, x equals 4. So I'm going to dash that in. Now my directions don't say to talk about the domain and range, but let's go ahead and do that like we've done before. So the domain is anything we can plug in for x that will give us real number outputs, and we can put any real number in. The range, however, is limited. Remember, we look at the y value of the vertex. Since it opens up, which is -1, so since it opens up, my y values are going to be greater than or equal to -1. And that's how you graph in intercept form. All right, now let's look at example 1 and graph it. So we've got f of x equals -2 times the quantity x minus 1 times x plus 3. Notice how this form of the quadratic equation is different from the ones we looked at in earlier concepts. It's got the 2 parentheses, so it's set up in intercept form. So you can pick out those 2 intercepts, p and q. So p will equal +1 because we look at what's being subtracted. Q will be -3. So that means I've got 2 points, 1, 0, and -3, 0 that I know already on my parabola. So I can place those in my xy table. Then I'm going to find my axis of symmetry, which is also the x value of the vertex. So I take p plus q and divide it by 2. So that will give me -2 divided by 2, which is -1. If I plug in -1 into my function, I will get 8. So now I have 3 points, and I can go ahead and graph my parabola using those 3 points. So I have the point 1, 0, -1, 8, and -3, 0. My axis of symmetry is at -1, so I'm going to go ahead and dash that in. And let's give the domain and range. So all real numbers can be used to plug in for x, and then my range, remember I'm going to look at the y value of the vertex, which is 8. Since this parabola opens down, then all my y values are going to be less than or equal to 8 to create that curve. Now, pause the video and do the independent practice problems, and then come back and check your answers. So the graph of function number 1, f of x equals 2 times x minus 5 times x minus 1, should look like this. So you should have picked out that your x-intercepts, your p and q values, are at +5 and +1. So that gives you the points 1, 0, and 5, 0. And then if you find the center of those, so we'll add them up and divide by 2, will be where x is 3. If you plug in 3 to the function, you're going to get -8. So there's your vertex at 3, -8. Now let's sketch in that axis of symmetry. Make sure you have yours. And then go ahead and add the domain and range if you didn't find that. You should get good now by finding the domain, which is all real numbers. The range, we look at the y value of the vertex, which is -8. Since our graph opens up, that means our y values will be greater than or equal to -8. And lastly, number 2, you should have a graph that looks something like this. Now this equation is a little different because you don't see the 2 sets of parentheses, but it still is in intercept form because you could think of a 0 next to that first x. So f of x or y would equal negative, and then we could go x minus 0 times x minus 6. So our 2 intercepts are at 0 and positive 6, and that'll give us the points 0, 0, and 6, 0. And then finding the center of those, so 0 plus 6 divided by 2 will give you the x value of the vertex at 3. If you plug 3 in, you'll get 9. So our vertex is at the point 3, 9. Axis of symmetry, you know, goes right through the vertex. It's the same value as the x value of the vertex. And let's talk about domain and range. So domain is all real numbers. Range, we look at the y value of the vertex, which is 9. Since it opens down, our y values will be everything that is less than or equal to 9 to create that curve. And that's how you graph in a quadratic in intercept form.